Okay, I think a couple of days ago I might have said that we're not going to have the antiderivatives of some of these. That was not true. I remember backing off of that as soon as I said it, but I did say it, and that was a mistake. So check this out. They all four of these require progressively more interesting tricks. Okay, so check this out. So let's say on this one, oops, there we go. Blue is fine. All right, let's rewrite this as the integral of sine over cosine. There we go. Good. Okay. Now, all right. So it says use a U substitution, man. I'm really not super thrilled about that idea, but I'll go ahead and go and do it. But we're looking at the denominator, and you're like, well, how do you know that? Well, because if we have fractions, we typically want the derivative of the bottom to be the top. Okay, and man, that is super close. So let's say I call call U cosine x. Okay. All right. Let's say that's what we think it is. And then that means that du would be negative sine x dx. Okay, which I just about have. I could make a little change here then, and I could say that dx, no, uh, sine x dx. Yeah, that's what we want to do. Sine x dx would equal negative du. Okay, and now let's make some substitutions. All right, so it will be the integral, and I have a negative, and sine x. So I have the negative. I pulled it out front. So the sine x dx that remains then will be du. Let's put that over here. And then I've got 1 over u. Okay. Well, that's natural log. So this is going to be the negative natural log of the denominator, because the derivative of the bottom is the top, right? Plus c. Okay. But we want to put, so it's going to be the natural log. And now cosine, of course, can be all over the place, but we don't need a natural log to be all over the place. So it's going to be absolute value of cosine x plus c. Awesome. Okay, so let's say I tried to do it without a u substitution. All right. So again, I'm looking at the denominator. I'd love the derivative of the top, bottom to be the top. And it would be if I did that. So now all of that now is the derivative. Wait. The derivative of the bottom is now the top. Sorry. So it's a natural log. So it would be negative natural log, absolute value, because you need them on that, cosine x plus c. All right. Okay, hey, how about b while we're here? It's a little bit quicker. All right, so let's say I do my pattern recognition way first. And so let's rewrite cotangent then as cosine over sine. Mm-hmm. And check it out. The derivative of the bottom is the top. We're good to go. So it will be natural log, absolute value, we need it for sine, plus c. So what we've done is then we've created a natural log out of a situation where these trig functions were fractions all along. But not only are they fractions all along, they're fractions such that the derivatives are close to each other because the derivative of sine's cosine, derivative of cosine's negative sine, we're able to make it work. Now, again, the use substitution here, if we were going to do it, and I guess I'll go ahead, would be to call the denominator. It's usually the denominator you want to deal with. Oh, eraser. All right, there we go. Okay, so let's call the denominator u. Okay, and then the derivative is going to be cosine x dx. Sweet. Okay, and so once again, the cosine x dx is du, so that's good, and this will be u. So so we can make a direct substitution. So we've got 1 over u du. Du replaced all of that. Okay, and then we're good to go. So this is the natural log, absolute value of u. Should have put that here. Ollie. Plus c. All right, so we got the natural log, the absolute value. You all right, buddy? Of u, which was sine x, our protector, plus c. Okay, there we go. So there's tangent and cotangent. And so the cotangent one, though cotangent is more complicated, or the one that you learned about later, it's the one that has the sign, and then the tangent is the one that's got the negative. So there